Okay, guys, discrete optimization. This is a transition lecture to tell you about how to explore the material and what is going to happen in this class. Okay, so I want to tell you about how you can explore the rest of the material, and I want also to tell you how you can study and how you can do the assignments and the various way you can be successful in this class. Okay, so it's something where I basically want to give you all the options that you can have. And we have designed this class in such a way that you have a lot of freedom. We are all about freedom in this class, okay? So first, we want to congratulate you. You have made it this far. But, I also want to set expectation right. So this was the easy part of the class, right? So you got the knapsack assignment. We gave you the algorithm. It's the easy part, okay? So what's going to come next is a nightmare, okay? It's going to be amazingly hard, okay? We won't give you the algorithm. We're going to give you the techniques that you can use, all these hats. But we won't tell you which one to use. We won't tell you how to use them. And we're going to make your life as much miserable as we can, okay? So that's the goal, okay? So essentially, we give you three kinds of techniques that you can apply: constraint programming, local search, and mathematical programming. They are beautiful techniques, okay? So, but once again, when you get a problem, you will not know exactly which one to use, okay? And so part of this class is about you getting an understanding of these techniques and finding out which one are good for which problems and which one to apply, okay? So this is essentially how the course is organized. It's completely open. We give you all kinds of freedom. So you have seen the intro of the material. And then essentially in the chronological organization, we give you CP and then local search and then MIP. But there is no reason you need to follow that. Okay, so you could jump from one to the other. You can start with another one. You can do all kinds of things. You can look at the introductory lecture for every one of these three, then go deeper in some of them and so on and so forth. You have entire freedom to actually explore this material. It's not going to disappear unless something really bad happened to Coursera, okay? But this is going to stay, and you can explore these things the way you want. And it is the same thing for the assignments. We are going to give you a bunch of assignments, and once again, there is a specific order which we think makes sense, but there is absolutely no obligation to actually do that. You can do assignments in a different order, or more likely, what you can do is start working on an assignment, having some initial solutions to them, and then leave them alone, solve another assignment, and then you become smarter and smarter. And then you can decide, but no, I can go back to this assignment and do a better job. And you can do that all the time. You are graded at the end, not at the beginning, not when the initial deadlines are. So you can always go back and refine these things. Complete freedom, okay? You can do whatever you want, okay? Isn't that nice? Okay. So one thing that I want to tell you also is a little bit of background knowledge of the various optimization techniques, okay? And once again, I'm going to exaggerate. So what I'm telling you now is a real lie, okay? But for beginners, it's mostly true. Even for sophisticated users, to some extent, it's true. But this is going to help you in actually figure out how you can get, what are the various things that you can do in this class. So if you use techniques, global techniques that are guaranteed to find the optimal solution if you leave them enough time, okay? Like CP, like MIP, like dynamic programming. What you will get is typically a method that gives you very high quality solution, optimal solution in general, if you give them enough time, but they won't necessarily scale that well to huge problems of very large sizes, okay? So in a sense, this is something that for a number of problems is going to give you optimal solution in this class, but for other problems, it's going to be very, very challenging to actually find optimal solution using these techniques, okay? Local search is the exact opposite. It's going to basically scale very well if you implement it correctly, but it may not give you the best solutions all the time, or even a high-quality solution. It depends really how you implement it, okay? But it's a completely orthogonal way of looking at the problem, okay? And of course, this is one of the hot topics in optimization these days. Hybrid algorithm will combine these two things to actually give you solutions which are of very high quality, for which you can actually give the quality, bounce on the qualities and things like that, okay? So this is like, the holy grail of optimization these days, okay? And so, you can actually do these three things. We don't expect everyone to kind of do hybrid algorithm. They are very sophisticated. We'll only talk about some of them in this class at the end. But you can use different techniques for different part of an assignment. I'm going to come back to that, okay? So keep this picture in mind when you are trying to solve the problems. And don't get frustrated, right? So if you try to apply a technique like this to a really really huge problems, you may get into trouble. And this is fine. We want you to get into trouble so that you get the intuition. Okay? So there are many ways you can be successful in this class, and I'm going to give you some of them right now. Okay? So there are many things you can do. Once again, it's about freedom and exploring many different things. Okay? One of the things that you can do is to say, okay, I'm going to use one technique, for instance, and apply it to everything. And of course, I know that I'm going to sacrifice something when I do that, but you can do that. Or you can say, no, I want to understand this material, like crazy, and I will apply all the techniques to all the problems. You can do that as well, okay? And all these approaches are going to be successful in some fashion, right? So for instance, assume that you want to focus on one of the techniques, like MIP or CP, okay? And you want to apply that to all the problems, okay? So this is like what we call a solution, a quality-based solution, okay? And what you do there is that for some of these problems, these approaches are not going to scale, so you won't be able to find the optimal solution. So when you look at a particular problem, okay, a particular assignment, most of these assignments will have about 6 parts, okay? And the complexity is growing. The size of the instances are growing, okay? So if you do a solution, a method which is based on finding very good solution, optimal solution, you are likely going to get optimal solution to some of these instances, let's say 4 of them, where you will have the maximum grade, and then some lower grade for the largest one, because that approach is not going to scale up, okay? You would get 46 points, for instance, okay? Now, if you do local search, for instance, you're going to scale nicely, but you won't find the best quality solution. And so let's say you will get a 7 for all these 6 instances, and you will get something which is like 42 points for that particular assignment. Both of these things, 42 and 46, are sufficient for you to get a certificate in the class and pass the class, right? And so this is nice, okay? You can do that. Of course, what we want you to do, really, deep heart, deep inside your heart, is basically you finding top solutions for every one of them, getting 10 everywhere. But that will mean that this is a significant, a more significant investment of your time. You need to actually, use some of the most sophisticated method on the smaller instance, and then use methods that are more scalable on the larger instances, okay? So these are the various ways you have to, you can try to do this class, okay? So you can look at the material and try to get a certificate, and that means that you can explore only some of the techniques, or you want really to do really well, and you have to use a combination of these techniques, okay? So various ways you can find, you can be successful in this class. Obviously, we encourage you to understand and master the whole material. Let me give you also some kind of feedback on what are the differences from a cognitive standpoint, essentially, for these various methods. They use different kinds of math, different kinds of techniques, okay? So constraint programming is all about discrete algorithm, discrete mathematics, solving puzzle. It's essentially a generalization of solving puzzle. And of course, it's a very nice generalization. It's beautiful, but this is something, if you like discrete math, discrete algorithm, this is where, this is something that's going to resonate with you very well, okay? Mixed integer programming is also beautiful, but it's very different. It's based on continuous math, linear algebra, and things like this, okay? And it has its own beauty, but it's a very different way of thinking than constraint programming. So this is about, pruning the search space. This is going to be about finding really clever relaxations and things like that. And we'll talk about these topics in detail, right? So in practice, both of these things are very orthogonal, and it's very good to know about both of them. But they require very different kinds of background, which is nice. In optimization, you get to touch on, upon many, many topics. And then local search is this completely different framework, which is very intuitive. When I give my kids, some of these puzzles to solve, they will always do local search. They put things around and try to fix them. That's what local search is about. But it's also, there is also a very systematic theory that we're going to go over later on in the class as well. Okay? So what you have to do here is much more intuitive. You can see things, and they correspond more to your intuition, at least initially. But they may require a lot of programming and experimentation compared to some of these techniques where we'll have more support if you use, available solvers. In all these 3 techniques, when you start looking at very complex instances, what you have to expect is that you will be spending a lot of time looking at your screen and wondering what these algorithms are doing. Okay? So there is a lot of experimentation in optimization. Okay? You may be lucky and find a really good solution initially, but most of the time you're going to look at this thing and say, why does this thing do this to me? Right? So there will be a lot of these cases that you will experiment. Okay? So but this is giving you a lot of the different background that you can have. Okay? So, select one way to proceed and you can adjust it over time. You have a lot of freedom. Find the way this class works for you. And remember, this is a lot of work. This is a very hard class. The knapsack assignment was the easy part of the class. Okay? And here, a lot of the focus of the class is discovering what works for which problems. And we don't take you hand by, I'm not going to take your hand and walk you through the various assignments. You will have to find the best way to use the techniques that we are covering to actually find good solutions to this assignment. Okay, good luck. Thank you. It's going to be a lot of fun and a lot of work. Okay, but a lot of fun. Thank you.